Let's learn a little bit about sound. Sound is a form of energy that spreads out through space. This guy here is trying to listen to a bell inside of this piece of glass, which is called a vacuum. And we'll talk about that in just a second. Okay, the origin of sound means it's the source of where it comes from. It's the source of all sound waves. Actually, the source of all sound waves is vibration. So that is what starts sound. Okay, the origin of sound means where does it come from? It comes from vibrations. So examples are vibrating strings on a guitar or in a piano. You know, the piano, when you plunk your fingers on it, a hammer hits a string back behind it. And that's why you hear that tone, okay? The vibrating reed of a saxophone or vibrations of a vocal cord in your voice. So me talking, really what I'm doing is making vibrations in my throat, and it hits the air and it makes these vibrations come out and then into your ear, and it vibrates your eardrum, and then you hear the sound. Pitch is our subjective impression about the frequency of sound. So when we say something has a high pitch, that means it's the sound, like from a rubber ducky, has a very high vibration. It vibrates really fast, so it sounds like it's higher. Let's see if this works. If it has a low pitch, it means the frequency is lower, and like a foghorn. Okay. Humans can hear pitches with frequencies from about 20 to 20,000 hertz. As we grow older, our hearing range shrinks, especially at the high frequency end. So my hearing, because I'm older, once you hit a certain age, you start to hear less of that upper frequency. And so when maybe a kid hears like a whining sound coming from the fluorescent lights or something, sometimes the older people, they can't hear it, so it doesn't bother them. Okay, so sound waves with frequencies below 20 hertz are called infrasonic. Sound waves with frequencies above 20,000 hertz are called ultrasonic. So infrasonic, not many things can hear it, and above 20,000 hertz. When you look over to the right, that dog can hear frequencies of 40,000 hertz, way up there. We can't hear that. It's so high pitched that our ears don't register it. And then bats can hear even higher, 100,000 hertz. That is crazy to me. Okay, sound in air. As the source vibrates, so here we hit this tuning fork on a hard surface and it makes a sound. It vibrates the air and compresses it. So a series of compressions and rarefactions is produced. So here we have the sound comes out and it pushes the air away from it, so the molecules kind of bump into each other, and then here's the rarefaction and they bump into each other, rarefaction, bump into each other, rarefaction. So it travels, the sound travels through the air until it hits our eardrum. Okay. So here it's like if you had a slinky and you were to push it, boom, and that would have a wave travel through that slinky just the same. See, we've got compression here, rarefaction, rarefaction, rarefaction. Okay. Okay, the speed of sound. Sound cannot travel in a vacuum. Remember this? Okay, we've got this piece of glass. There is a seal at the bottom, and then at the top they can suck the air out, and there's no air in there then. So if there's no air in here, there's no molecules for it to push in the air. So you will not hear that bell ringing. You just won't. That's why out in space you can't hear sounds. There's no molecules out there to hit against each other. Sound travels slower than light. Okay, so if sound travels slower than light, we look at this lightning. The lightning strikes. We can see it, but we can't hear it right away if we're far away from it. If we're right there, yeah, it'll seem like it's right at the same time. But if you are a mile away, you see the light first, and then you count 1001, 1002, 1003, 1004. Boom, then you hear the thunder. And that's because light travels faster than sound through the air. So you can count 1001, 1002, 1003, 1004. For every second you count, it will be 1/4 of a mile away, approximately. So how far away would that lightning be if you counted to 4? It would be a mile away, yeah. Okay, speed of sound differs in different materials. Like, I think the next one kind of explains it. Sound is transmitted faster in liquids than in gases. So sound travels faster in water. That's why it sounds so weird when we're like underwater swimming and we hear something. The sound is traveling faster, and it's still faster in solids. So if you were next to a train track, you could put your ear down to that train track. Don't do it. That's very dangerous. But you could put your ear down to that train track and feel that vibration before you, and maybe even hear you'll hear that train coming with your ear down to that track before you see it. Okay? All right. Intensity of sound. The unit of intensity is the decibel. An increase of each 10 decibels means that the sound intensity increases by a factor of 10. So 10 decibels is 10 times as intense as 0. So this is 10 times as loud as this. So normal breathing is 10 times as loud as what we can hear, the hearing threshold. 20 decibels is 100 times the amount of 0. So this is worth 10, this is worth 10, but you times them together. So what would 30 decibels be for intensity compared to 0? If there was a 30 up here, how many times more intense would it be than 0? So if you said 10 times 10 is 100, times 10 would be 1,000. So something right up here at 30 would be 1,000 times more intense than 0. So an old subway train is 1,000 times more intense than a busy traffic light or street traffic. A busy street traffic is 1,000 times more intense than a library, sitting in a library. Street traffic is 10 times as intense as a normal speech. Okay, it gets a little confusing, but you can figure it out. Okay, so hearing damage begins at 85 decibels. So if you are subjected to 85 decibels for a long period of time, it can damage your hearing and your eardrum, because your eardrum isn't meant to bounce back and forth so much. Okay, so the damage depends on the length of exposure and on frequency characteristics. Okay, so here is 85, just below a average factory. So if you go into a factory, people are wearing their earbuds, like little ear protectors, or they put the big ear protectors on. But what if you go to rock concerts all the time and you don't wear hearing protection, which most people don't? That's 30 decibels higher than where you can get ear damage. So that gets tough. Jet engines are 140. That is really high. Now, you'll notice people out, if you go flying, in a plane, you look at the people working on the tarmac, they all have ear protection.